Welcome to Learn Yourself. Today we are going to learn and understand about chapter Water from the ICSE Standard 8 syllabus. So these are the general information about water, that next to air, water is the most essential compound for human life and for the biology and the ecosystem of the earth. About 70% of Earth's surface is covered with water. These are the sources of the water which we are using. So snow and frost, they are natural forms of water. Rainwater is considering as the purest form of natural water. River and lake, yes, they are reservoir of the water. We are taking drinking water from that, but they are impure form of natural water. Sea water is considered to be the most impure form as it contains soluble sodium chloride, that is NaCl. Well, spring water, they exist below the earth's surface and contains soluble impurities. So these are the sources of the water which we are using on the earth. Henry Cavendish was the scientist who was the first one to discover that water is a compound and it contains hydrogen and oxygen into that. So as per the above information, water is present in all the animals and in all the plants, and it will remain in them in combined and in the free state. Potable water, or the water which we are using for our routine life and for the drinking purpose. So here we are going to study about the characteristic properties and qualities of potable water or drinking water. What qualities of the water will make water drinkable and good for the consumption. So what is a potable water? Which is fit for human consumption and drinking purpose. That is known as potable water. Now what all are the characteristic and qualities of potable water? Then it should be clear, colorless and odorless. Second thing is it should be free from harmful bacteria, germs, suspended impurities and harmful salts. Now what all are the salts which are harmful for us? Then nitrates, nitrite and cyanides and ureas. This type of salts are harmful for our consumption, so it should be free from this kind of salts. Then third one is it should contain small amount of dissolved gases, salts and minerals, which will give good taste to the drinking water. This point is very important, and this also tells us the scientific reason about why boiling water does not have a good taste, or we do not feel like to drink boiled water. Why is it so? Because when we will boil, it will separate out all the minerals and salt from that, and it will expel out all the gases what all dissolved in that. So boiled water will loses its taste. When it is in the normal form, it tastes good. So it should contain small amount of dissolved gases, salts and minerals which will give a good taste. Now what all are the salts that should be present into the water? Sodium, calcium and magnesium. These are good for our body also, and they are useful for metabolic function of our body. So salts, minerals and dissolved gases are doing two functions to drinking water, that they will impart taste to the drinking water, and also salts and minerals are useful for our metabolic function of the body. Now let us understand what is the need of potable water. That quantity of the water on the earth is about 70%, and that is very huge. That surface water on the earth is in a huge quantity, but this water is mainly a part of sea or a frozen ice. So actual drinking water is very less. So quantity of the water on the earth is about 70%, but only a small percentage constitute a potable water. So only small percentage of water we can consider as a potable water or drinking water, because major portion of the water is from frozen ice or from the sea water. So they are not fit for the consumption. Then river and lake water, sometimes they are not good for the drinking purpose because of the contamination. Now what all kinds of contamination will be there in a drink water? So dissolved carbon dioxide, suspended impurities, decaying, dead and decaying organic matter, clay, sand, all this will get mixed with the drinking water and then it will be no more a potable water. Second thing is disease causing germs comes from human waste and industrial waste. So these germs will cause diarrhea, typhoid and jaundice like disease into humans. So they are also considered as not fit for the consumption. So that's why the need of potable water is very high, because we have only small portion of the drinking water, and that too the river and lake water are mostly contaminated and they are also sometimes not considered as a drinking water, or it is not characterized under quality of potable water. Water is also called a universal solvent. So what is the reason behind that? That there are two basic reasons and main reasons for that. That water can dissolve large amount of substance like salt, sugar and many chemicals. Second point is it can also dissolve gases like carbon dioxide, ammonia and hydrogen chloride gas. So it can dissolve solid substance also, it can dissolve gases also. And since it can dissolve majority of the common substance and gases, that's why it is known as universal solvent. Now what is the meaning of solution? When we are taking one solid substance, that we are dissolving it into a solvent. Solvent means any liquid. For example, if I am taking a salt and I am adding that into a water. So here the solid substance is salt, so that will be considered as a solute. And water is a liquid substance, it will be considered as a solvent. So here this solute is considered as a solid substance and solvent, water is considered as a liquid substance. So the substance which will get dissolved into a liquid, substance which will dissolve into a liquid and make a mixture, that is known as solution. So combinedly solute and solvent will make a solution. Let us see the definition of solute, solvent and solution. What is a solute? So the dissolved substance is solute. The substance which dissolve in a liquid, that is solvent, to form a solution is known as solute. For example, salt. It will dissolve in a solvent called water and it will form a solution. So the substance which will dissolve in a liquid, that is solvent, to form a solution is known as solute. What is a solvent? The substance which will dissolve the solute is solvent. Now solution is mixture of solute and solvent and it should be a homogeneous mixture. For example, if we are adding a chalk dust or a charcoal powder into a water, it will not dissolve, it will float on the surface of the water. It will remain undissolved, it will not disappear into the solvent. So this is an important condition for the solution to form, that it should be a homogeneous mixture, that you will not be able to see a particles of solute separated from the solvent. It should mix homogeneously so that you will not be able to see the solute particle into the water. So the homogeneous mixture of solute and solvent is known as solution. For example, if we are dissolving salt or sugar, it will get completely dissolved into a water and they are forming a homogeneous solution. So they are called solution. But if you are adding a chalk dust or a charcoal to the water, then it will not make homogeneous mixture or homogeneous solutions. So they are not a solution because they will not get dissolved into a water. Now when we are making a solution, we have to keep in mind some of the conditions and some of the factors, the formation of the solution. So these are the factors and conditions that we have to keep in our mind when we are making a solution. So first one is solubility of solute in a solvent. Solute should be dissolved properly into the solvent, then only it will be called a solution. If we are adding a charcoal in a water, then it will not dissolve, then it is not termed as a solution. But if we are dissolving sugar and salt to the water, then it is called solution. So solubility of solute is important when we are making a solution. Second thing is proportion of solute and solvent. When we are making a solution, solute should be of less amount and solvent should be of more amount. For example, salt and water. So salt should be less compared to water. So amount of solute should be less compared to solvent. Third factor is particle size of solute. So it should have a small size, it should dissolve quickly. If the particles or the crystals of the solute is very large, then it will take time to dissolve and sometimes it will remain undissolved. So that should not happen. So that's why whenever we are taking a solute, it should be of a small particle size so that it will dissolve quickly. Fourth condition is temperature of the solvent. Sometimes if the solute is not dissolved completely in a solvent, then we are heating the solvent slightly and it will increase its solubility. We are going to see this concept in detail when we are going to learn a saturated solution. So here we are keeping in mind that when solute is not dissolved completely in a solvent, we can heat a solvent little bit or slightly and we can increase its solubility so that it will dissolve some more of a solute. Fifth condition is proper mixing of solute and solvent particle. When we are mixing any solute into a solvent, we are using a glass rod. With that, we are stirring it continuously and we are dissolving it. It is very important step, and because of that, the solute and solvent will mix thoroughly, completely, and it will make a homogeneous mixture. So that's why proper mixing is important. With related to the solubility of the solvent, there are two types of solution. First is unsaturated solution and second is saturated solution. Let us first understand about unsaturated solution. So I have taken here one beaker full of water. Into this, the water is there, and I am adding 2 spoonfuls of salt into that. After adding this much salt, I am stirring it and making a solution. But if after this is the first step, and at the second step, if I will add one more spoonful of salt, then also this water is going to dissolve it. So still this water has a capacity to dissolve. That's why it is called as unsaturated solution. That it is not completely saturated. The capacity of solvent to dissolve a solute has not been completed. It can dissolve some more solute to that. So at this stage, after first step, this solution is considered as unsaturated solution. It can dissolve some more salt into that. So that's why it is known as unsaturated solution. Till the time solvent has a capacity to dissolve some more solute into that solution is considered as unsaturated solution. Unsaturated solution means the solution which is not saturated. Then what is the meaning of saturated solution? After adding 5 spoonful of salt, now some of the salt will remain at the bottom of the beaker because now it cannot dissolve some more salt. After adding 5 spoonful of salt, it is not dissolving some of the salt and it will lie at the bottom of the beaker. Then this solution is considered as a saturated solution. Why it is considered as a saturated solution? Because to dissolve solute, the capacity of the solvent to dissolve a solute has completed. It is completely saturated. Now it cannot dissolve some more of a solute. So that's why it is known as saturated solution. Until the stage that solvent can dissolve more and more solute into that, it is referred as unsaturated solution. But the moment it will stop dissolving more of a solute, it will become saturated solution. Saturated solution means it does not have capacity to dissolve more solute. So that's why it is referred as saturated. Where here it can dissolve some more solute to that. That's why it is known as unsaturated solution. So let us see the definitions of these three important terms. That unsaturated solution is the one that solvent can dissolve some more solute to form a solution is known as unsaturated solution. And all these things will happen at given temperature or room temperature or T degrees Celsius. So when some more solute we can dissolve into a solvent, then that solution is termed as unsaturated solution. Saturated solution is the one that solvent does not have more capacity to dissolve some more of a solute is termed as saturated solution. Now what is the meaning of solubility of solute? That maximum amount of solute that we have to measure into a gram that will saturate 100 gram of water at room temperature, that will considered as a solubility of solute. Solubility in water will get affected by three major factors. First is temperature. Second point is what we are taking as a solute. Solute can be solid, liquid and gas. Let us see our first point, that is temperature. When we are increasing a temperature, then solubility of solute will increase slightly. But some of the solutes solubility will increase drastically and with larger amount. That first example will tell us that solubility is increasing largely. That at 46 gram of potassium nitrate we can dissolve in 100 gram at 30 degrees Celsius. So when temperature is 30 degrees Celsius, we can dissolve only 46 gram of potassium nitrate. But when we are changing a temperature, when we are increasing a temperature up till 100 degrees Celsius, we can dissolve 240 gram of potassium nitrate in 100 gram of water. So this is the difference, that solubility has increased largely. In second example, solubility is increasing slightly even if we are changing a temperature. So here this is an example of sodium chloride NaCl, that at 20 degrees Celsius only 36 gram of NaCl will get dissolved in 100 gram. But when we are increasing the temperature up till 100 degrees Celsius, it can dissolve only up to 39.5 gram of sodium chloride. So here we can see that solubility has increased slightly. So it is depending upon solute, that with temperature the solubility is increasing largely or slightly. Second point is liquid plus liquid. Here we are taking our solute in liquid form. The two liquids will mix with each other, and solute liquid we have taken which will get dissolved into a water. So one of the liquid will be our solute. That proportion will be less and the water proportion will be more, because water is a solvent and that's why its proportion should be more. So here two types of liquids will be there when we are adding liquid as a solute into water. So miscible liquids and immiscible liquids. When we are mixing alcohol into a wet water, it will make a miscible liquids, that they will mix well. You cannot identify the particles of the alcohol into the water. They mix well with each other. That's why they are called miscible liquids. But immiscible liquids are which will not mix completely. For example, oil and water. We can spot the particles of the solute into a water. Kerosene plus water. So particles of the kerosene, the droplets of the kerosene and oil will float in the water. So that's why they are not mixed with each other and it is termed as immiscible liquids. Our third factor is solubility of gas into a water. That means as a solute we are taking gases. So first thing is, with temperature it will decrease. If we are boiling a water, then it will expel all the dissolved gases out. And that's why boiling water tastes flat. When we will boil the water, all the dissolved gases will expelled out and it will taste flat. Because the gases and the minerals and salt will impart taste to the water. With pressure it will increase. So when we are increasing temperature, the solubility of gases will decrease. But when we will imparting or applying pressure, the solubility of gases will increase. And the example is soda water. So soda contains carbon dioxide dissolved in it under pressure. Pressurizing condition, the carbon dioxide gas will get dissolved into a soda water. And hence, when we are opening the bottle cap, it will releases its pressure and we can see some of the effervescence of carbon dioxide will come out. So that is the reason we can see some effervescence of carbon dioxide will come out. The solutions. So basically three types of solutions are there: true solutions, colloidal solution and suspensions. So first we are going to learn about true solutions and we'll see the conditions for the true solution. When we can say that this solution is a true solution, first thing is it should be a homogeneous mixture. It should be evenly mixed and we should not be able to see the solute particles in a solvent. Second is particles. These are the characteristic properties of the particles, that how the particles should be and how they should mixed into a solvent. That first, they should not be visible once they'll get mixed. The solution can pass through a filter paper and so as solute. We know that when we are keeping a funnel like this is a glass funnel, into that we are keeping a filter paper. So this solution should pass from the filter paper, and on top of the filter paper the solute should not remain. It should pass along with the solvent. So it can pass through a filter paper, that much evenly mixed the solute should be in the solvent. It can diffuse through semi-permeable membrane also. Can be seen under ultra microscope, and it should not settle down. Settle down means when we are adding a sand into a water. After some time, because the sand is heavy, it will settle down and the top of the liquid, that is water, will get cleared after some time. If we will leave it undisturbed, then solute and solvent will get separated. That should not happen when we are mixing a solute into a solvent. If they'll get separated after some time, then it is not a true solution. So for all the time, it should get thoroughly mixed with the solvent. So always whenever you are referring a true solution, you can take an example of salt plus water. That even if after some time the salt will remain dissolved into a water, it will not get separated from the water, because so as it is considered as a true solution. And third is we can recover solute by physical method. Physical method means evaporation. Evaporation means we are not doing any chemical reaction on solution. So that is termed as physical method, as it is a mixture and not a compound. Solution is just a mixture that we are physically mixing two ingredients. One is a solute, one is a solvent. So there are some of the physical methods like evaporation, filtration and all. This method are considered as a physical method, that it will not involve any kind of chemical reaction. So mixtures will get separated via physical method. So this is also a mixture. We can separate the mixture through physical method, as solutions are not a compound, they are mixtures. Our second solutions are colloidal solutions. These solutions may look like homogeneous solutions, but actually in nature they are heterogeneous solutions. And their particles are in intermediate state in between molecule and ions. They are not visible through naked eye. They can pass through filter paper, but they cannot pass from semi-permeable membrane. It can be seen under ultra microscope and it will do not settle down. Even though they are heterogeneous mixture, they will not settle down, as sand will get settled after some time in a water. They will not settle down. They will show a random movement into a solvent. They will show a Tyndall effect. Now what is the meaning of Tyndall effect is when we are passing a beam of light through a solution, then it will scatter a light, and because of that the path of light will be visible through the solution. That effect is known as Tyndall effect. So scattering a beam of light due to heterogeneous particles, because these particles are big enough, when we are throwing a beam of light through this solution, the particles remain into a solvent will scatter a light, because they are big and they will scatter a light, and that's why the path of light will be visible. That here if we are keeping a torch, then path of light will be visible throughout the solution. That effect is known as Tyndall effect. As an example of colloidal solution, we can take milk drops into a water. So that is a perfect example of colloidal solutions. So these were the characteristic properties of colloidal solutions. Our other type of solutions are suspensions. So they are heterogeneous mixture. Undissolved particle in dispersion medium is termed as suspension. For example, sand and water. Particles are visible through naked eye. It cannot pass through either filter paper or semi-permeable membrane because they will remain undissolved into a solvent. They can be seen under ultramicroscope and it will settle down after some time. That solute and solvent will get separated after some time because they are undissolved into a solvent. About water of crystallization, some of the important crystals and some of the important substance. So let us start with the water of crystallization. Before going into the detail of water of crystallization, let us first understand the crystals. What do you understand when I say a crystal? Crystal means a sugar crystal or a salt crystal. You can see that they are having a specific geometrical shape. Like that, there are so many other geometrical shape of chemical substances. Tetrahedral or a diamond shaped crystals are also possible for a chemical substance when you are converting a chemical substance to a crystals. So what are the crystals? The solids having regular symmetrical arrangements are known as crystals. For example, sugar crystal. Now what is a crystallization? So the process of making a crystal from a substance is known as crystallization. And how we are going to do that? By making hot saturated solution. Earlier in the segment of the saturated, unsaturated and supersaturated solutions, we have seen how to make supersaturated solution. That once the saturated solution is made, we are heating it, we are extending a capacity of solvent to dissolve more of a solute after heating it, and then we are dissolving some more solute. So first step is by making hot supersaturated solution, and once we are making hot supersaturated solution, the second step is by cooling it gently, or we are keeping it undisturbed at room temperature. We are allowing it to cool gently and normally. After that, we can see that how much ever solute we have dissolved, that will recovered, and we will see that the normal substance will take a shape of crystals, and whatever solute we are recovering here will be in the form of crystal. So this is the process of crystallization, and that is how we are making crystal or recovering the crystal from the solution. Then what is water of crystallization? When we are making crystals, from this process some of the water molecule will enter into a loose chemical combination of the substance. Let us take one example of CuSO4. It is copper sulfate, but when we are writing 5H2O along with that, that means these are crystals, and these 5 molecules of water are loosely combined with copper sulfate. It is not into the molecular formula of copper sulfate, but it somewhere held up in between the atoms of copper and sulfate. And this number of water molecules which are held up into the copper and sulfate, that number will be fixed. That when copper sulfate crystallization will happen, only 5 molecules of water will attach to them, and this water is known as water of crystallization. Now this water of crystallization impart 2 characteristics to substance. First thing, it gives geometrical shape. And second thing, that color to the crystals and color to the substance. So when copper sulfate will become crystallized and the water of crystallization will get attached to them, this substance will convert into crystals. So we will get to see the crystals and it will also impart color to this. So that's why we will get to see the blue color crystal of copper sulfate. So what is a characteristic property of this water of crystallization? That for each and every hydrated crystal, that means the fixed number of water molecule will be attached to a loosely bound molecule, that is copper sulfate, and this number will be fixed. And it will enter into the molecule and it will impart two things to the crystal. That it will give crystalline nature to the substance and it will become blue color or any other color. So that means it will impart color also. Now there are two types of crystals. One are with water. They are termed as hydrated crystals, and the crystals which do not have any kind of water molecules along with them, they are termed as anhydrous crystals. So here hydrated means definite number of water molecule in loose chemical combination with the crystals. Again, these water molecules are not along with the water molecular formula. Once you will heat it, it will get evaporated and you will get only crystal left behind. So that's why they are just only loosely held along with the molecular formula. That these water molecules have not entered into the molecules with the crystals. They are just loosely bound together with the molecule. So definite numbers of water molecule in loose chemical combination with the crystals. These crystals, once you will heat it, this water molecule will get evaporated and you will get anhydrous crystals. That's why it is known as hydrated crystal. Hydra means water and hydrated crystal means it is along with the water. Anhydrous crystals means it do not contain any definite number of water molecules. Now how to identify hydrated and anhydrous crystals from the molecular formula? So here two sets of molecular formulas are there and it is very easy to identify the crystals along with the water molecule, and they are termed as hydrated crystals. These are hydrated crystals because as you can see here, the water molecule is attached with that. See that here we are writing a dot and then we are writing definite number of molecules attached with the molecules of the crystal. This is washing soda, sodium carbonate, and only one water molecule is attached to that. CaSO4, calcium sulfate, and two water molecule is attached with that. Copper sulfate and 5 water molecules are attached with that. That means one molecule of copper sulfate are having 5 molecules of water. Another copper sulfate molecule will have another 5 molecules of water, and so on. So that's why these are loosely bound along with the original molecular formula. Once you will heat it, this water will get evaporated and whatever is left behind is a substance which will not have any crystals, and if the water of crystallization is imparting any color to that, then they will lose the color also, because this water of crystallization are imparting two things to these crystals: color and crystalline nature. Now these are the crystals which do not have any kind of water molecule along with that. So that's why they are termed as anhydrous crystal. So it's really easy to identify the crystal whether they are anhydrous or hydrated. There are three types of crystals. They are termed as efflorescent substance, deliquescent substance, and hygroscopic substance. According to their nature, we have given them a special name, that efflorescent, deliquescent, and hygroscopic, but ultimately they are crystal only. So based on which characteristic we have given them a separate name, that we will discuss it now. So efflorescent substance, they are crystalline and hydrated substance or crystals. What are the hydrated crystals? That the loosely bound water molecule will be together with them. So they are termed as crystalline hydrated substance, lose water to atmosphere. So when we are keeping it open into the atmosphere, they are tend to lose water to atmosphere. So this is their characteristic property. They are hydrated crystal and they tend to lose water to atmosphere. And after that they will changes to the amorphous powder, because we know that this water, that water of crystallization are imparting crystalline nature to the substance. So once they are losing it, they will convert again to the amorphous powder. There are two types of substances, crystalline nature and amorphous. Those are not crystals, they are termed as amorphous. They are powder like substance. So it will convert again to amorphous powder. So these are efflorescent substances which are crystalline hydrated substance. They will tend to lose water when we are keeping them open, and ultimately they are converting back to the amorphous powder. And what is the example? That copper sulfate hydrated, pentahydrated will convert into copper sulfate anhydrous crystals. Then comes the deliquescent substances. They are crystalline water soluble substances, and when we are keeping them into the atmosphere, they will absorb moisture from the atmosphere, and after that they will changes into saturated solution, because how much ever they can absorb the moisture, they will absorb from the atmosphere, and they will, from the crystal they will turn into saturated solution. An example is FeCl3, that is iron chloride crystals. Once we are keeping them open, they will turn into iron chloride solution, and this solution will be saturated solution. Then comes hygroscopic substances. They are amorphous solid or liquid compound. They will absorb moisture from the atmosphere, but they do not change their original state. For example, calcium oxide solid will remain calcium oxide solid only once they are absorbing moisture from the atmosphere. They do not tend to change their state. They will remain solid after absorbing moisture also. So there are three types of crystals. Hydrated crystals, which are losing moisture to the atmosphere and become anhydrous. Deliquescent crystals, which are absorbing moisture from the atmosphere and become saturated solution. And hygroscopic substance, which are absorbing moisture but remain same or remain solid after absorbing moisture also. So there are three types of substance based on their characteristic properties. Along with the crystalline substance, there are three types of agents. There are termed as drying agents, desiccating agents and dehydrating agents. These agents are easy to remember as their function is based on their name. That drying agents will absorb or remove the moisture from the other substance. So when we are using this substance, for example concentrated H2SO4, calcium oxide and P2O5, that is phosphorus pentoxide, they will help us to remove moisture, and it will absorb the moisture, it will remove the moisture from the substance. So that's why they are termed as drying agents, which will dry the other substance. Then comes the desiccating agents. The agents or the substance which we are keeping in apparatus called desiccator. Desiccator is an apparatus which we are using in a chemistry laboratory to keep a substance free from the moisture. So they are termed as desiccating agents because we are keeping them into the desiccator. They are kept in a desiccator and used for drying a substance. For example, fused calcium chloride we are using as desiccating agents. Then comes dehydrating agents. As name suggests, they will remove the water molecule. Hydra means water and dehydrating means removing water. So they are removing water from the substance, that's why they termed as dehydrating agents. They remove chemically combined water from the compound. See here, it should be chemically combined. When we are writing CuSO4 5H2O, so this is not chemically combined. Once you will heat it, This substance will evaporate whatever loosely held water molecule is there along with that. So this is not chemically combined, but here we are talking about chemically combined. So whatever chemically combined water molecule will be there, that water molecule will get removed once you are using this dehydrating agents along with that. This process is a chemical reaction and followed by chemical reaction. So when we are taking a glucose molecule and we are adding concentrated sulfuric acid to that, then we will get as a product 6 hydrogen and 6 water molecules. So here water molecules were within this molecule and that have been detached, that have been chemically removed by the action of concentrated sulfuric acid. So concentrated sulfuric acid is termed as dehydrating agents. Here concentrated sulfuric acid we are using as drying agents also. When we are passing any gas from the concentrated sulfuric acid, it will remove moisture from the gas. So that's why we are using concentrated sulfuric acid for both the action, as a dehydrating agents also, as drying agents also. Reactions of water with different metals. Here I have represented activity series of metal, where the metals are at the top. They are more reactive compared to the metals are placed below them. So here if the potassium is placed above sodium, that means potassium is reactive compared to sodium. That also means that potassium, sodium and calcium, they all three are reactive compared to all these metals which are placed below them. Here we have also placed hydrogen along with all the metals, because hydrogen also behaves like metal with all the other compound. So that is the reason that why we have placed hydrogen also along with other metals. Let us go into detail and see what all metals are there. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, that is Pb, hydrogen, copper, Hg is mercury, silver, platinum and gold. In your textbook, maybe this last order will vary, but you can stick to your textbook, and I have referred this order for the metallic series. So here first reactions we are checking along with these three metals, that is potassium, sodium and calcium. These three metals are referred as very reactive metals and they will react with cold water. When any metal will react with water, they will produce hydroxide, that is potassium hydroxide, sodium hydroxide, calcium hydroxide, and leaving behind hydrogen gas. So this is a generalized equation for the metal when reacting with water, that it will give us metal hydroxide plus hydrogen gas. So whatever metal you will take, that you have to place it over here and it will form a hydroxide. Hydroxide means OH. So OH will combine with the particular metal. Now it is depending upon the molecular formula, that which molecular formula they will make. So here KOH, that is potassium hydroxide, here it is NaOH, sodium hydroxide, and this is calcium hydroxide, CaOH twice, because we know that OH's combining capacity is 1 and calcium's combining capacity is 1. So via crisscross method we will get a molecular formula, that is CaOH twice. Since OH is polyatomic ion, we have to place OH in between the bracket and we have to write 2 out of the bracket. So that is CaOH twice. All these three metals will react with cold water, that they are very reactive, do not need any kind of temperature. The reaction of sodium, potassium and calciums are vigorous along with the water. As soon as they will come in a contact with water, they will start burning. So these reactions are very vigorous, and the reason behind that is these metals are very reactive. Magnesium, aluminium, zinc, iron, lead and hydrogen also react with water, and these reactions are less vigorous compared to the above reaction, because these metals, yes, they are reactive, but they are less reactive compared to sodium, potassium and calcium. So these reactions we have to perform along with the steam or along with the boiling water. Within this series also, the magnesium's reaction is more vigorous compared to aluminium, because magnesium is reactive compared to aluminium, whereas aluminium is reactive compared to zinc, and so on. So magnesium will react with boiling water and will give us magnesium oxide and hydrogen. So here the generalized reaction is this metals will react with water and will give us metal oxide. These are metal oxides, where metals have reacted with oxygen. So metal oxide plus hydrogen gas as byproduct. So this is a generalized reaction. When this series of metals will react with water, they will give us metal oxide. That is magnesium oxide, aluminium oxide, iron oxide, and they all will leave hydrogen behind. Now the remaining metals, that is copper, mercury, silver, platinum and gold, they all are just after hydrogen. That means they are less reactive compared to the hydrogen. In a water molecule, the formula is H2O. So we have to replace hydrogen. Metal needs to react with water, then metals are electropositive. They need to replace hydrogen from the water compound. Then only they will be able to react with either OH or oxygen. But here these metals are less reactive compared to hydrogen, so they cannot displace hydrogen from the water molecule, and that's why they will not react with water. That copper, mercury, gold, platinum and silver will not react with water because they are less reactive compared to hydrogen. They will not be able to displace hydrogen from the water molecule. Reaction of water with metallic oxide and non-metallic oxide. Now what is the meaning of metallic oxide? When metal will react with oxygen, it will form metal oxide. That is, metal is reacting with oxygen and it will form a molecule that is referred as metal oxide. For example, potassium will react with oxygen and it will form metal oxide, that is potassium oxide. So here all the metals will react with oxygen and form metallic oxide. When non-metals like sulfur, carbon, they will react with oxygen and they will form an oxide. These oxides are referred as non-metallic oxides. So for example, sulfur will react with oxygen and it will give us sulfur dioxide. So this is termed as non-metallic oxide, and these are termed as metallic oxides. So when metallic oxides will react with water, they will give us metal hydroxide. And here when non-metallic oxide will react with water, it will give us respected acids. So K2O, potassium oxides, will react with water, it will give us potassium hydroxide. Sodium oxide will react with water and it will give us sodium hydroxide. Calcium oxide will react with water and it will give us calcium hydroxide. Now these are the non-metallic oxides. Sulfur dioxide will react with water and it will give us sulfurous acid. SO3, sulfur trioxide, will react with water and it will give us sulfuric acid. Carbon dioxide will react with water and it will give us carbonic acid. So these are the compounds which are termed as acids. So when non-metallic oxides will react with water, it will give us acid, whereas here metallic oxide will react with water and it will give us hydroxides. Soft water, hard water, and causes of temporary and permanent hardness in the water. So first one is hard water. When the water is said to be hard. So water is said to be hard when it does not lather readily with ordinary soap and hence the soap will be wasted. It requires more of a soap to show its action. And why is it so? Because substances like calcium and magnesium salts will be present in them. calcium and magnesium salts, that is bicarbonates, sulfates and chlorides. That means calcium bicarbonates, magnesium bicarbonate, calcium sulfate, calcium chloride, magnesium sulfate and magnesium chlorides are present into the water, and that's why the water will be said to be hard, because it will not give effective action along with the soap. Now there are two kinds of hardness into the water. First is temporary hardness and second is permanent hardness. Temporary hard water is the water whose hardness can be removed by boiling. If we will boil the water, then water will become soft and practically we can use that water for the washing. And this temporary hardness is due to the calcium bicarbonate and magnesium bicarbonate. So among these salts, the bicarbonates are causing the temporary hardness. That is, calcium and magnesium's bicarbonate are causing temporary hardness. This temporary hardness we can remove it via boiling. So these are the salts which are responsible for the temporary hardness. Now permanent hard water is the water whose hardness cannot be removed easily by boiling, and this hardness will be there due to the substances present into the water, and this substance and these salts are calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. So these two salts, that sulfates and chlorides of calcium and magnesium, these two are responsible for permanent hardness of the water. These salts we cannot remove via boiling, whereas these salts we can remove via boiling. What is the reason behind that? Because here, as you can see, this is bicarbonate and carbonate is there along with that, so that will be removed via boiling, whereas these chlorides and sulfates are hard to remove via boiling. So that's why this is permanently remain into the water. We cannot remove it. That's why it is named as permanent hard water, and this is temporary hard water. Now let us see the chemical reactions of removal of temporary hardness and permanent hardness from the water. So here, this is removal of temporary hardness. We know that when there is a temporary hardness, there will be a presence of bicarbonate salt into a water. So this is a formula of bicarbonate salt of calcium and magnesium. Calcium bicarbonate and magnesium bicarbonate. When we are boiling these two, we will get calcium carbonate as a solid residue or solid substance. This arrow suggests that this compound or this substance will precipitate out such that we can filter it out from the solution. So this arrow tells us it will be a solid substance and we can filter it out. So calcium carbonate and magnesium carbonate will precipitate out as a solid substance. Water will remain there and carbon dioxide will expel out as a gas. So this is in the form of gas and it will expel out while we are boiling the water. So these are the products of this reaction, whereas this will precipitate out, which we can filter it out. Carbon dioxide gas will automatically expelled out from the water, and remaining this water we can term as a soft water, because now there are no more impurities of bicarbonate salt into this water. So now residual water is termed as soft water. When we do not know that hardness of water is because of which kind of salt present into them, then we can use washing soda. And washing soda will act upon both the type of hardness, that is temporary hardness and permanent hardness, and it will give us soft water. So these are two reactions in which washing soda, that is sodium carbonate Na2CO3, will react with permanent hardness of the water and temporary hardness of the water. Again, permanent hardness of water is because of the sulfate and chloride salt of calcium and magnesium, whereas temporary hardness of the water is because of the bicarbonate salt of calcium and magnesium in the water. So here washing soda will act upon sulfate salts also and bicarbonate salt also. So when it is dealing with permanent hardness, we will get calcium carbonate and sodium sulfate as a product. So calcium carbonate will precipitate out, whereas sodium sulfate will remain in the water and it will not interfere into a washing action. It will not create any type of hardness into the water. When washing soda will react with temporary hardness of the water, that is calcium bicarbonate or magnesium bicarbonate, it will give us here calcium carbonate and sodium hydrogen carbonate. Here two salts are from calcium, that is calcium sulfate and calcium bicarbonate. We can also take here magnesium sulfate and magnesium bicarbonate. With respect to that, we will get here magnesium carbonate and magnesium carbonate. Here this carbonate salt will precipitate out, which we can filter it out, and remaining these two substances will remain dissolved into the water. So this too will precipitate out, which we can filter it out, and remaining water, the residual water, will be termed as soft water. So hope this video has cleared your doubt. In coming segment we are going to discuss many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.